Today's lesson we are going to look at chemistry 1502 resonance structures is the topic for today. We are going to look at lesson 101. Let us start. Our first example, let us determine the resonance structure for this. By the way, this arrow represents the resonance structures. Now what will happen, this double bond will move to this oxygen, then you're going to have something like this. And these electrons will move to this position. And by the way, this becomes positive. So we know that positive and negative, there's a force of attraction. And then we know that the behavior of electrons and protons, only electrons can move, protons cannot move. So we are going to have something like this. This is one of the examples. Now let us explain the ways we can actually do this. There are certain rules that we follow when drawing resonance structures. Now the first rule, atoms are fixed and cannot move. Now the only things that take part in the resonance, it's only the electrons, the pi bonds and the lone pairs. So the atoms cannot move, cannot change positions. Like for example, this oxygen cannot trade places with this one, or this carbon cannot trade places with this oxygen. So in simple terms, we only focus on the lone pairs, the pi bonds. So that is one of the rules. The atoms are fixed and it cannot move. Let us look at the second rule. Only lone pair electrons and pi electrons can move. Now in this case, considering our previous example, these are lone pairs, and then pi bonds, we only find them in triple bonds and double bonds. So this one, they cannot move, since we can see it's single bonds, this one and this one. So the only electrons which will participate in the resonance are lone pairs and pi bonds. So this is one of the rules that we should also consider when we are drawing resonance structures. We should always consider and take note, be careful of the octet rule. Remember that we have divalence, we have tetravalence electrons. Like fluorine, it only needs one electron to reach the octet state. Carbon, it needs 4 electrons to reach the octet state. So whenever you draw resonance, we should take note and always be careful not to break the octet rule. Like for example, we are still going to use the previous structure. If we actually shift this pair of lone pair this direction, we are going to have something like this. We cannot leave it like this because we are actually breaking the octet rule or octet state for carbon. You can see that it's bonding 5 times instead of 4. So after doing that, automatically we need to also shift this pair of electrons so that we obtain something like this. So this will be an invalid resonance structure but you can see this one is correct. Now let us look at the next rule. Electrons flow in one direction. Now suppose we have the very same example. We cannot have this pair of electron flow in this direction and also this pair of electrons flow in this direction. We can see that they are against each other. Instead, this will flow this direction. Actually, let me put it this side. So they flow in one direction. Let us look at the next rule. Electrons normally flow from high electron density to low electron density. Now this rule, we are actually going to see it or speak about it in detail when we look at different examples. Now let us look at examples. Let us find a resonance structure for this. So this will move this direction, and then this pi bond will also move this direction. Then we are going to have, actually let us take it step by step. When we shift this pi bond to the oxygen, we are going to have a single bond, this will gain a negative charge, and then we still have our double bond here. Now since this becomes negative, our carbon here will become positive. And then we said electrons, they normally flow from a region of high electron density to low electron density. So we can see that we have this pi bond here. Then since here it's the region of high electron density, and then this is the region of low electron density, this pi bond will shift this direction. Then we are going to have something like this. So this is the resonance structure for this molecule. For this one, we can actually have a number of resonance structures. Now what we can do, we can take this pi bond, it moves to the region of low electron density. As you can see, this carbon, it has a positive charge. So when we move this pi bond to that new position, we are going to have something like this. Then we still have our pi bond there, and then the positive charge will jump 2 carbons away from the new position. Then we are going to have our positive charge here. And then this structure also has a resonance structure. What we can do, we can take this pi bond and bring it here, and then our positive charge will come here. Let us look at the next example. Let us look at this one. You can pause the video and try to find all the resonance structures for this structure. So the first thing that we can do, we can take this pi bond and bring it here, and then the new position of the charge will be actually here. Then from here we can generate another resonance structure by taking this pi bond and bring it here. then we're going to have something like this. From here again, we can do something. We can actually take this lone pairs and bring it here, and this positive charge will come here. Let us look at our last example. Let us find all the resonance structures for this structure. So this pi bond can come here. Then this carbon will be positive. We are going to have something like this. Can also take this pi bond and put it here. We take this pi bond, we put it here. That's it for this lesson video. This is Bahula AJ. Thank you very much.